Okay guys, so this is chapter 3, problems. Chapter 3 is dedicated to discuss ionic bonding and simple ionic compounds. And today we'll look at the problems that will be asking you, for example, on page 148. Why are some ionic compounds, not some, all of them, unlikely to consist of two positively charged ions? And the answer is very easy because positive ions repel each other. That's why they cannot make a compound. Ionic compounds like to consist of one positively charged and another negatively charged ion. Question number 2 is asking similar question. Why is an ionic compound unlikely to consist of two negatively charged ions? The answer is pretty much the same. Negative ions repel each other and therefore they do not like to form an ionic compound. So let's look at the question number 3. A calcium atom has two valence electrons. Do you think it will lose 2 electrons or gain 6 electrons to obtain an octet in its outermost electron shell? So, metals that are located in the first column, second column, some of the transition metals that are located in the middle of periodic table, they love to lose their electrons. Usually, those elements will give away their electrons to form a bond. Calcium is located in the second column and it loves to give away its electrons. Any metal on the first or second column will lose those electrons and will become a positively charged ion, which is also called cation. Question number 4 is asking, an aluminum atom has 3 valence electrons. Do you think it will lose those 3 electrons or gain 5 electrons to obtain an octet in its outermost electron shell? As you remember from reading the book, you need 8 electrons to fill out an octet. You cannot have more than 8 electrons. So usually metals would love to give away their electrons to lose those electrons. So non-metals will fill up that octet. Aluminum is a metal and aluminum ion is a cation. It will lose those 3 electrons. I'm sorry, not ions. Electrons. Let's move on. A selenium atom has 6 valence electrons. Do you think it will lose 6 electrons or gain 2 electrons to obtain an octet in its outermost electron shelf? Selenium is an ion, which means it's a negatively charged ion. It has a negative charge to it. And it will gain 2 electrons because it's so much easier to gain 2 more electrons. Second of all, it's actually non-metal. Non-metals love to accept those electrons. And it will gain 2 electrons to fill up its outermost electron shell. Question number 6. An iodine atom has 7 valence electrons. Do you think it will lose 7 electrons or gain 1 electron to obtain an octet in its outermost electron shell? Iodine is a nonmetal. It is located in group number 17. Therefore, ion is an anion, which I said before is negatively charged ion, and it loves to gain electrons. So it will gain 1 electron to obtain an octet in its outermost electron shell. Okay, page 156 is asking what are those 2 types of ions. So the question is not very correctly made. So what are the two different types of ions? So there are two different types of ions. There are cations, the ones that have a positive charge, and anions that have a negative charge. Question number 2 is asking about Lewis diagrams and how do you illustrate the formation of ionic compound of potassium. I gave you an example, but we will be covering Lewis dot structures next class, so I don't want you to concentrate too much on it. If you know how to do it, that's good. If you can review it already, but Lewis dot structures are going to be reviewed next week. So I know that the question is asking between potassium and iodine. I gave you something different. Potassium and chlorine. Chlorine and iodine are located in the same column. Therefore, they have same chemical characteristics and they will be reacting the same. And as you can see, potassium over here has 1 electron because it's located in the first column, and chlorine has 7 electrons because it's located in the column 17. Chlorine needs only 1 more electron to fill up its octet. Remember, octet needs 8 electrons. Then the element is happy, ion is happy, right? And this potassium has 1 extra. He doesn't want it, so he wants to donate this electron to chlorine. Therefore, when potassium will lose its electron, it will become +1 charge. He lost its negative charge. It was negative, right? And now he's positive because he lost that negative charge. When you, from 0, when you -1, it becomes not negative anymore. It becomes positive, right? If you would be adding negative electron, then it would be a neutral element. But since chlorine gained 1 extra electron, its charge become 1 minus or -1. So when these two react, they create this compound called potassium chloride. Question. When the following atoms become ions, what charges do they acquire? So, I'm not sure what ions they're asking about, but you can look up in the table that I provided to you. And it's very easy to find the answers if you look it up. So anyone in the column 1, any of these atoms, elements in column 1 will get a charge +1. Any element in column 2 will get a charge +2. This is a little bit difficult and it's a little bit gray area, so we're not going to discuss this at the moment, but here are the most common examples. For example, like silver or zinc or aluminum. As you can see, this is their charge, right? These are all metals and they have different charges. These are already non-metals and they have negative charges. So like nitrogen and phosphorus will have -3, oxygen, sulfur, and selenium will have -2. Anyone in column 17 will get -1. These elements, do not like to gain or give away their electrons, and they called inert, and they usually have a 0 charge. There's no charge. They're neutral. Okay. Oh, here continues the question. So what about lithium? You look up first column, then the charge is +2. Sulfur in column 16, therefore the charge is -2. Calcium is second column, so it's metal, get the charge +2. Fluorine, here's our fluorine, get a charge -1. You're not going to have these charges on the periodic table. You just need kind of to remember what it is. +1, +2, +1, +2, +3, and over here is easy as well. It's -3, -2, -1, and 0. Okay. Page 157. And the first question is asking you identify each as a cation, as anion, or neither. Just a review, cation is something that is positively charged, anion is negatively charged, and they will give you an example sometimes that there is no charge, just to confuse you or check if you do actually understand the topic. So question A is a hydrogen with a positive charge +1. This is definitely a cation. B is a chlorine, actually chloride ion, with a negative charge, therefore it's anion. Question C is diatomic oxygen, doesn't have any charge, therefore it's neutral ion. So it is neither. Barium has a charge +2, it's a positively charged ion, so it's cation. This is called methane or CH4. It has no charge, and this compound is neither, it's neutral. Here's another example, is FCS2, carbon and sulfur is a compound that is neutral, and therefore it's neither. Identify each as cation, an anion, or neither. Same type of an example. So this is a ammonia. Common name is ammonia or nitrogen trihydrogen. This is neither. This is a neutral compound. This is bromide ion and has a negative charge, therefore it's anion. This is a hydrogen that has a negative charge. It can happen, and therefore you look at the charge. If it's negative, then it's anion. This is something interesting. Write the electron configuration for each atom. So remember how we did in chapter 2, writing electron configuration for neutral isotopes. Now we will be writing electron configurations for ions. So it can gain 1 electron or lose 1 electron, and we will calculate it. Nothing complicated, you just need to have the correct number of electrons. How do you find the number of electrons? You have to have a periodic table with you. In order to find out the number of electrons, you have to know where is the atomic number located. When you look at the atomic number, you know the number of your electrons, and then you have to calculate. So for example, lithium has 3 electrons because its atomic number is 3. Over here it has a positive charge, +1, right? Therefore, it lost 1 electron. So you have to subtract 1 from its total number of electrons. Therefore, it's going to be 2. And then you start to fill up your subshells. 2 electrons is very easy. 1s2. We didn't have to do anything else. 2 electrons over here. You're all done with your electron configuration for this example. For this cation, lithium cation. Okay, next one is magnesium. Magnesium, this example of magnesium has a positive charge 2, right? It lost 2 electrons. That's why it has a positive charge. So magnesium has an atomic number of 12. So it has 12 electrons. So from your total number of electrons, you have to deduct 2 electrons that it lost. Because for this magnesium, it will have only 10 electrons. And then you start to fill up your subshells. This is something that you actually need to memorize. How do you fill them up? What is the next energy level? What is the next subshell? How many electrons in the subshell? This is something you need to memorize. This is not something you can just look up easily. So 2 electrons, we need 10 total. 2 electrons plus 2 electrons plus 6 is equal to 10 electrons. So the electron configuration for magnesium 2+ is going to be 1s2, 2s2, 2p6.